In this video, we are going to cover the sum and difference of sine. Now, this is a trig identity that is pretty much a staple as you go through the rest of your identities, even into calculus. Notice that your signs on the left and right side of the equal sign are the same, so sine a minus b will give you a minus here, sine a plus b will give you a plus here. If you look at just the right side, you notice that the a and b, which would be your angle, are in the exact same spot, and your sine and cosine are both in the exact same spot. So you're going to have sine a cosine, cosine a sine b, sine cosine, cosine sine. That's your patterns. Now we can look at some problems and see how you apply that. So let's look at our first problem. Here we have sine of 15 degrees. Now that's pretty much just what your problem is going to look like. Now the way to solve that, to save time, I've already solved it and I'll just go through all the steps. To get sine of 15 degrees, you would have to use the sine a minus b. If you come back to your unit circle, the only way you can really get 15 degrees is to subtract 30 degrees from 45. So coming back to the problem, you have your sine a cosine b minus cosine a sine b. And you really just plug in those values. So 45 would be your a, and 30 would be your b. So the sine of 45 degrees, and you just go back to your unit circle. It's cosine first, sine second. So you just plug each one of these in for each value. So the sine of 45 is root 2 over 2, so on and so forth. And then you just multiply straight across, just like your original equation shows you. So root 2 times root 3, you get root 6 over 4. The side you're going to get root 2 over 4. Now those you can't really do much with, so your answer is just going to be root 6 minus root 2 over 4. Some teachers will have you sort of factor out the 1/4 and write it like this. It really just depends on which book you're using. Now let's move on to another problem. Now this is the problem that you are really lucky if you get on an exam. Here you have a problem which is basically just the right side of an equation. So if you look at that, that looks just like the sine a cosine b minus cosine a sine b, which is right here. Now that is equal to sine a minus b. So if 82 degrees is your a and 37 degrees is your b, all you have to do is subtract the b from the a, just like it shows up here, sine of a minus b. So the sine, 82 degrees minus 37 degrees will give you 45 degrees. It's that simple. As you know from your unit circle, the sine of 45 degrees is root 2 over 2. And that's your final answer. All you have to do when you see the right side of this is just add the a and the b, or subtract the b from the a. All depends on which sign you have right here to determine which one of these equations you're going to use. And now let's have a look at the third problem that I prepared. Now, if your trig professor is a little sadistic, as they tend to be, they may give you problems with this in radians, which is pretty much the same as degrees, as I showed you how to convert in the previous video, but you would do the exact same thing. Here's this sine a plus b, where you really would just identify your a and your b and add them together. So this is just the right side of an equation, which is equal to sine a plus b. So once you recognize that pattern, these become very easy. So it would become sine a plus b, which is the sine of pi over 4 plus pi over 2. When you add those together, you would have to go back and review your fractions. So to get a common denominator between these two, the common denominator is 8. So you multiply this one by 2 and the right one by 2. You end up with 6 pi over 8, which reduces to 3 pi over 4. Just convert that to degrees. Either look on your unit circle here. You see that 3 pi over 4 is equivalent to 135 degrees. Or if you know that pi equals 180 degrees, you can just do a quick calculation in your calculator to get 135 degrees. So, as you know, the sine of 135 degrees is root 2 over 2, or you can leave it in radians. Sine of 3 pi over 4 is root 2 over 2. It's in the second quadrant, so the sine would be root 2 over 2. If it was cosine, that would be negative, but I don't want to get into that and confuse you. That's for another video. And there you go. I hope this video was helpful. Please rate, comment, subscribe.